Hello, grade 8. Our math lesson today is about fractional expressions and proportionality. Fractional expressions. Literal fractional expressions. A literal fractional expression exists or is defined when its denominator is different from 0. 4y plus 5 over y plus 7, 3x plus 1 over x, and 2 over 3t minus 1 are three literal fractional expressions where x, y, and t are variables. Examples. The literal fractional expression 2y minus 1 over 3y minus 18 is defined for 3y minus 18 different than 0. Then 3y is different than 18 and y must be different than 6. The literal fraction x plus 3 over negative x plus 2 is defined for negative x plus 2 different than 0, then negative x is different than negative 2 and x must be different than 2. The literal fraction m minus 7 over m squared minus 16 is defined for m squared minus 16 different than 0. M squared minus 16 is written as m minus 4 times m plus 4. Therefore, m minus 4 times m plus 4 is different than 0. When a product must be different than 0, then both factors must be different than 0. Therefore, m must be different than 4 and m must be different than negative 4. The literal fraction for y plus 5 over y plus 7 is defined for y plus 7 different than 0, then y must be different than negative 7. The literal fraction 3x plus 1 over x is defined for x different than 0, and the literal fraction 2 over 3t minus 1 is defined for 3t minus 1 different than 0, then 3t must be different than 1, and t must be different than 1 over 3. Simplification of a literal fractional expression. To simplify a literal fractional expression, 1. Determine the values of the variables so that the expression would be defined. 2. Write, if necessary, the terms, which are the numerator and the denominator, as product of factors. 3. Cancel the common factor of both terms. Examples. Simplify e equals x to the power of 2 minus 1 over x plus 1 to the power of 2. E is defined for x plus 1 to the power of 2 different than 0. Then x must be different than negative 1. E is written as x minus 1 times x plus 1 over x plus 1 to the power of 2. We wrote the numerator as a product of factors. Now we simplify by x plus 1. We obtain e equals x minus 1 over x plus 1. Simplify f equals 25 a to the power of 6 b to the power of 2 c to the power of 4 over 10 a to the power of 4 b c to the power of 5. E is defined for 10 a to the power of 4 b c to the power of 5 different than 0. Then a must be different than 0, b must be different than 0, and c must be different than 0. If you simplify by 5a to the power of 4 b c to the power of 4, you obtain f equals 5a to the power of 2b over 2c. Reducing to the same denominator. To reduce many fractional expressions to the same denominator, 1. Simplify these expressions, if necessary, after the conditions of existence have been determined. 2. Choose the simplest common denominator, and 3. Find the equivalent fractions. Reduce to the same denominator the fractional expressions 2x to the power of 2 plus xy over x to the power of 2 and z to the power of 2 minus 2xz over xyz. Simplify both expressions. 2x to the power of 2 plus xy over x to the power of 2 is defined for x to the power of 2 different than 0, then x must be different than 0. The fractional expression is written as x times 2x plus y over x to the power of 2. If you simplify by x, you obtain 2x plus y over x. Z to the power of 2 minus 2xz over xyz is defined for x different than 0, y different than 0, and z different than 0. The fractional expression is written as z times z minus 2x over xyz. If you simplify by z, you obtain z minus 2x over xy. The simplest common denominator of both fractions is xy. The equivalent fractions are y times 2x plus y over xy and z minus 2x over xy. Addition and subtraction of fractional expressions. To add or subtract fractional expressions, 1. You simplify these expressions after the conditions of existence have been determined, then you reduce them to the same denominator. 2. You add or subtract the numerators. 3. You simplify the answer if possible. Examples. Calculate f equals to a over b minus 4 over 3a plus b over 3. F is defined for a different than 0 and b different than 0. The simplest common denominator is 3ab. F is written as 6a to the power of 2 over 3ab minus 4b over 3ab plus ab to the power of 2 over 3ab, which is equal to 6a to the power of 2 minus 4b plus ab to the power of 2 over 3ab. Calculate g equals a minus 2 over a plus 2 plus a plus 2 over a minus 2 minus a to the power of 2 plus 4 over a to the power of 2 minus 4. G is defined for a plus 2 different than 0, so a must be different than negative 2. And a minus 2 must be different than 0, so a must be different than 2. Also, a to the power of 2 minus 4 must be different than 0. Then, a minus 2 times a plus 2 must be different than 0. Therefore, a must be different than 2, and a must be different than negative 2. The expression is written as g equals a minus 2 over a plus 2 plus a plus 2 over a minus 2 minus a to the power of 2 plus 4 over a minus 2 times a plus 2. The common denominator is a plus 2 times a minus 2. G is equal to a minus 2 to the power of 2 over a plus 2 times a minus 2 plus a plus 2 to the power of 2 over a minus 2 times a plus 2 minus a to the power of 2 plus 4 over a minus 2 times a plus 2. The answer is a to the power of 2 plus 4 over a to the power of 2 minus 4. Multiplication of fractional expressions. To multiply the fractional expressions, 1. Simplify these expressions, if possible, after finding the condition of existence. 2. Multiply the numerators, then the denominators. 3. Decompose into factors both terms of the obtained expression. And 4. Simplify. Perform the following products. 1. To x over x minus 4 times x to the power of 2 minus 16 over 8 is defined for x minus 4 different than 0 if x is different than 4. To x over x minus 4 times x to the power of 2 minus 16 over 8 is written as 2x times x minus 4 times x plus 4 over x minus 4 times 8. Now we can simplify both the numerator and the denominator by 2 times x minus 4. The answer is x times x plus 4 over 4. 2. 1 plus 4x over 1 minus 4x times 1 minus 4x to the power of 2 over 1 plus 4x to the power of 2. This expression is defined for 1 minus 4x different than 0. Therefore, x must be different than 1 over 4. And 1 plus 4x to the power of 2 different than 0. Then x must be different than negative 1 over 4. Now we simplify both the numerator and the denominator by 1 minus 4x and 1 plus 4x. The answer is 1 minus 4x over 1 plus 4x. Division of fractional expressions. To divide a fractional expression by a second one, you multiply the first by the reciprocal of the second one. When performing operations on fractional expressions, if some parts of the expression are whole numbers or expressions without a denominator, consider their denominator to be 1 and apply the rules. Example. Calculate q equals x to the power of 2 minus 4 over 3x divided by x minus 2 over 6x. Q is written as Q equals x to the power of 2 minus 4 over 3x times 6x over x minus 2, defined for x different than 0 and x different than 2. Q is then written as x minus 2 times x plus 2 over 3x times 6x over x minus 2. I can simplify both the numerator and the denominator by 3x times x minus 2. Q would be equal to 2 times x plus 2. Proportionality, proportion. A over B and C over D are two equal ratios. The equality A over B equals C over D is called a proportion. A is the first term and D is the fourth term. They are called the extremes. B is the second term and C is the third term. They are called the means. Since A over B equals C over D, therefore we can write A times D equals C times B, A over C equals B over D, D over B equals C over A, and B over A equals D over C. Directly proportional magnitudes. Two magnitudes x and y are directly proportional if you obtain the second number y upon multiplying the first number x by the same number k. K is the proportionality coefficient. Y equals kx. Since y equals kx, we conclude that x is equal to 1 over ky. Therefore, x is directly proportional to y. The numbers a, b, and c are directly proportional to 4, 6, and 8 means that a over 4 is equal to b over 6 is equal to c over 8. Example. In this table, I can find y over x. I notice that 7.5 over 3 is equal to 10 over 4 equals 15 over 6 equals 25 over 10 equals 5 over 2 or simply 2.5. So y over x is equal to 5 over 2. Therefore, 2 times y is equal to 5 times x and y is equal to 5 over 2x, or I can simply write y equals 2.5x. Y is directly proportional to x. 2.5 is the proportionality coefficient. Example. Divide the number 60 into parts directly proportional to 2, 3, and 5. If we designate these three parts A, B, and C, then A over 2 equals B over 3 equals C over 5, since the three parts are directly proportional to 2, 3, and 5. And I can also write that A plus B plus C equals 60. Suppose A over 2 equals B over 3 equals C over 5 equals T. A over 2 equals T gives A equals 2T. B over 3 equals T gives B equals 3T. C over 5 equals T gives C equals 5T. But A plus B plus C equals 60. Therefore, I can write 2T plus 3T plus 5T equals 60. 10T would be equal to 60. T would be equal to 6. Consequently, I can write that A is equal to 2 times T equals 12. B is equal to 3 times T equals 18. And C equals 5 times T equals 30. Inversely proportional magnitudes. Two magnitudes x and y are inversely proportional if there is a constant number k such that x times y equals k. If x is different than 0 and y different than 0, from x times y equals k, we conclude that x equals k times 1 over y and y equals k times 1 over x. Therefore, one of the magnitudes is directly proportional to the reciprocal of the other one. Example. We notice that 1 times 20 equals 2 times 10 equals 4 times 5 equals 20. So x times y equals 20. The magnitudes x and y are inversely proportional. The numbers a, b, and c are inversely proportional to 4, 6, and 8, means that 4 times a equals 6 times b equals 8 times c. We can also write a over 1 over 4 equals b over 1 over 6 equals c over 1 over 8. Therefore, a, b, and c are directly proportional to the reciprocals of 4, 6, and 8. Example: divide the number 61 into parts inversely proportional to 3, 4, and 7. If we designate these three parts A, B, and C, then 3 times A equals 4 times B equals 7 times C, and A plus B plus C equals 61. Suppose 3 times A equals 4 times B equals 7 times C equals T. In this case, A would be equal to T over 3, B would be equal to T over 4, and C would be equal to T over 7. But A plus B plus C equals 61. So T over 3 plus T over 4 plus T over 7 equals 61. The common denominator of 3, 4, and 7 is 84. So this equation is written as 28t over 84 plus 21t over 84 plus 12t over 84 equals 61. 61t over 84 equals 61. T would be equal to 61 times 84 over 61, so T is equal to 84. Consequently, A equals T over 3 equals 84 over 3, which is equal to 28. B equals T over 4, which is equal to 84 over 4, equals 21. C equals T over 7, which is equal to 84 over 7, equals 12. That's it for now. Thank you for watching.